Cloud is getting hyper inefficient, hyper centralized, and look what happened now in last month alone. AWS went down 4 times, took almost all the internet with it. So it's clear that centralization has failed. There is no other future that's not decentralized because the current model cannot scale. With the demand AI is bringing, we as a society is unable to meet the demand when it comes to energy needs. So Akash is, in simple terms, a peer-to-peer marketplace for compute resources.
I believe Akash is looking for a new home for the protocol.
Primarily because the
Hey, Sohejl here. Thanks for tuning in. Real quick before we begin, if you enjoyed this episode, if you learned something, please consider to follow or subscribe or share this episode. That helps us out a lot. It helps us to reach more people and to spread quality education across the space about crypto and Web3. Also, if you're part of a crypto project or represent one and you would like to come on the show or do sponsoring, please get in touch with us. And lastly, everything we talk about today is for educational purposes and no financial advice. Enjoy the show. All right, man. Greg, lovely to have you on the TEACHMEDEFI podcast.
Great to be here, Sohejl.
Awesome. Let's get right into it. I mean, we were chatting a bit earlier about decentralized compute and Akash, obviously, the project you founded, and decentralized compute is a central topic there. So just curious about decentralized AI, decentralized compute in general. Like, what's your opinion on it? Are these promising segments, or is there a lot of running the whole decentralization narrative all over again, just on a new piece of technology? What's your opinion, and where does open source maybe fit into all of this as well?
Yeah, I mean, it's a broad question, but when it comes to AI, rather take a step back. Decentralization is exceptional when you have networks with high inefficiency, right? So look at Bitcoin. Bitcoin is a solution to the inefficient cash transfers and inefficient store of value, right? And if you look at this segment in decentralization and crypto called DePIN, or decentralized physical infrastructure networks, it is an answer to infrastructure networks that are highly inefficient, right? Akash being a solution to inefficient way of distributing compute resources, right? So if you break down compute, it really comes down to, well, the actual hardware and physical chips and computers, to the power and the bandwidth that this compute needs to operate, right? So it's several layers of infrastructure that are highly inefficient. And what's happening with AI is, with the demand AI is, bringing to the grid, we as a society is unable to meet the demand when it comes to energy needs. And we're starting to see the cracks happen already. Just yesterday, I believe, the data center in San Jose, multiple data centers in San Jose are running out of power. They're shut down. This was predicted by Gartner in a few years ago. They said by 2026, 40% of data centers will go out of power without energy, because energy infrastructure is not as fast, or we cannot build energy infrastructure as fast as we can build data centers. So that's the challenge right now. What is the solution to the problem? Obvious. It's not that we don't have enough energy. We have a lot of energy. The problem is there is not an easy way to move energy around, because energy moves on the grid, right? So a grid is, if you break it down, just a bunch of copper wires that are connecting. And these copper wires run on land. And nobody wants new copper wires. Nobody wants to upgrade the copper wires. Nobody digging the copper wires underground is extremely expensive and complicated. So it's very hard to move energy if you produce, if you produce energy one place and you consume the energy somewhere else. So The only really way, real practical way to solve the problem is to move the workload to where the energy is. Now, you have to do that um, using distributed technologies and decentralized technologies, right? So that's the solution of the problem. The narrative for decentralization moves layer by layer, right? So in the beginning, when Akash was founded, Akash was an answer to this hyper centralization of compute. And when we wrote the paper in 2017, we said, look, the cloud is getting hyper inefficient, hyper centralized. We're going to start seeing problems with stability, with prices, and accessibility. And look what happened now in this last month alone. AWS went down 4 times, took almost all the internet with it. It causes such a disruption every time a data center goes down that it's almost like decentralization sells for itself, right? And look what happened in 2023 when you have this sudden surge in interest for AI, catalyzed by OpenAI's ChatGPT launch. We had every developer wanting access to GPUs, and there's just not enough GPUs the cloud providers could give, right? Because the world has been trained on the notion that cloud is a go-to for compute, and that go-to failed in 2023. That created an incredible opportunity for these companies called neoclouds, be it Corvi, be it all these companies that nobody knew come into spotlight because they could get access to GPUs. Now that's really what also put Akash to on the map. I remember amazing stories that came out of this 2024 era where there are kids in colleges couldn't get access to GPUs on Amazon because Amazon would only select the customers based on who pays the highest, and a lot of folks were priced out, folks that were doing innovative stuff. And Akash was their go-to because Akash is set up in a manner that no one can select you, is open to everybody. All the promises Akash made come to fruition when he sees examples of this one student from Cornell couldn't get GPUs on Amazon, came to Akash, could get his GPUs, built a company that eventually sold to NVIDIA, right? Those are just some of the success stories we see that came out of decentralization, without which that success stories wouldn't exist. So it's clear that decentralization is working for people that where centralization has failed. And it's clear that the energy crisis is going to create an enormous opportunity for distributed infrastructure to really shine. Granted, we've solved problems around distributed training, incentivization, and whatnot. But so my take is there is no other future that's not decentralized, because the current model is not only failing, it cannot scale. Like, there's really no solution to the energy problem. I mean, it takes a Manhattan level effort, Manhattan project level effort. Even then, there's questions about property rights and questions about what we can do. While we have our competition from a nation state level, which is China, that's building a gigawatt of solar capacity every 36 hours. There's nothing that we can do to achieve that rate of growth from a national effort standpoint. The only way to solve that is through figure out how to distribute workloads, and that's my take on decentralized AI.
I guess energy is a critical piece of this, especially with AI being so energy hungry, I guess. There's also all these announcements, right, that there'll be nuclear power plants next to data centers and things like that, which kind of aligns with your point that you need to localize the energy production, or do you have to have it close by to be able to use it?
Yeah, we either bring energy to where the data centers are, or we take the data centers to where the energy is. But energy and data centers need to be in the same place at this point. Ideally, you want to tap into an existing infrastructure instead of building new infrastructure to be more efficient. So the nuclear reactors are great. I mean, they're probably the most efficient way to generate energy. Unfortunately, the world has stumbled upon them for a while. In America, we have about 96 nuclear reactors that are fully utilized about 93% of the time. The last one we built took about 14 years. Nuclear is great, but we cannot build them fast enough. It's hyper-regulated. So there are all kinds of challenges when it comes to establishing nuclear capability very quickly. The SMRs, so small modular reactors, are still not market ready. And fusion is 10 years away, right? So we have the biggest nuclear reactor right above our roofs, right? In the sky called the sun. So if we can leverage solar effectively, we can solve a lot of problems. And the way we do that is homes, right? So solar is not a great solution at utility scale in the sense like producing mass amounts and transporting that. Without getting into specific, the challenges with battery, which is storage, the challenges with solar panels itself and cooling and whatnot. But it's great when it's dual or multi-purpose. At home, it's dual purpose because I'm using solar to power my home, charge my car, and if I can use the same solar to power a data center, maybe a small home node or a home data center, we have a dual purpose or multi-purpose solar, which is phenomenal. And your marginal cost of energy is zero at that point, right? So that's what I meant by solving this problem, energy crisis, by going into the home. Of course, is it efficient in terms of training? Not there yet. We are able to train using home computers about 7 billion parameter models now. Still very small, but the models are getting bigger and bigger and more efficient in terms of training. I'm pretty sure in the next 12 months, we'll see a state-of-the-art model trained over the internet using heterogeneous methods.
I guess for inference, for the actually like using AI instead of training, that could be less of a big problem, right? Like, I mean, you could run a 70 billion parameter model on an H100, even though H100 is still a bit pricey maybe for a person to just have at home. But like, what kind of hardware are you thinking people could be running at home with the solar power?
5090s, right? So we can have 6 5090s, 30 to 100 watts of capacity. I mean, we did the math. H100s are not economical at home in terms of ROI. Also, inference is challenging a bit because it does demand quite a lot on the bandwidth more than energy, and inference is a lot more distributable in the sense like to run a Llama, I think you need 8 H100s. And you can get 8 H100s in smaller data centers. It's not like we don't have, data centers with energy. We do have smaller data centers that can serve inference workloads. And inference is also like latency sensitive. So because you need to reduce amount of network in latency. And so you need to have these jobs running in pretty much every city, just like telcos. And there's a lot of telco data centers that can service these workloads. The real challenge is, I think the real opportunity is training more than inference, unless you're using local inference. So that changes the equation a little bit. What I meant by local inference is like when you have robotics, right? We're going to bank on the fact that it's going to be a robotic world, and it's already starting to happen right now. I mean, we're seeing with Neo, home robots and whatnot. In the world of robotics, the robots themselves are not very powerful because they need a lot of energy to power bigger chips. Even 5090s are off limits for most robots, right? Because 5090s take like 600 watts of energy, which is a lot for a robot. So there could be a world where you have a home node cluster powering inferencing the robot for additional, more intelligent tasks, where the robot will do like most of the autonomous tasks. And you can see a world where you have local networks. So, for example, if you're on Comcast, for example, you can have Comcast to Comcast, a home on Comcast, and homes and Comcast connect with lower latency, right? So there's a case to be made there. You can have local clusters, but for the most part, the challenge in home is going to be bandwidth to serve reliably. If Starlink can produce 1 gigawatt. I mean, Starlink does about 400 to 500 megawatt capacity, Mbps right now. There could come a day where it could do over a gigabyte to 2 gigabyte capacity. That's, I think, that's when we will start seeing a more effective, inference at home. But if you do the math, I think 59 disks will be the most optimal in terms of home networks. H100s are not competitive at home. I mean, and plus they're very expensive. Each chip is about $25,000 to $30,000, depending on who you buy from. And you need to have at least 8 chips, and that's going to be the demand on energy is extremely high. I don't think there are other challenges that are grid related challenges to have that much amount of energy at home. So it's not exactly a practical solution.
Well, let's take training then, because like in my mind, in decentralized networks for compute, there's always like 2 issues to solve, right? Which is confidentiality and verifiability. So for one, how do you assure that this data you're sending to this random person, random node is staying private, right? And if the use case demands it, but a lot of them do, right? And then the other thing is, how do we verify that the computation is actually carried out the way that we're expecting? I mean, maybe they serve back like let's stick with AI inference. Maybe they serve back the output of a much smaller LLM and save on energy costs, whereas the user is expecting a much larger LLM computing on their input. So how do you think about these 2 things in that context? Like for training, for example, like how do you know that this person running their node at home is actually computing what this network is expecting for the training purposes?
Yeah. So we made incredible progress over the last few years on verifiability. A big favorite for verifiability today is trusted execution environments, where it is vendor attested workloads, essentially attested at the chip level. And with memory encryption, it's impossible to at least see inside a workload when it is encrypted at the memory level, right? So you have multiple levels of encryption with TEE. First level is obviously transport level, which is not TEE related, but the encryption all the way from your machine to the remote machine. And then you have memory encryption at execution level. That means your memory is encrypted. So you can't, even if you have physical access, you can't see what's in the memory. And third is obviously at the CPU level, which is also using TE, right? So it's fully encrypted. The overhead we notice is about 20%, so which is acceptable, right? So it's going to be 20% slower, but if your workloads demand it, you're okay. But the energy costs are so low, you will have you will be able to account for the loss, the overhead costs, basically, right? So you're okay. And there are other solutions where you have TE, could be challenging. So Akash has a hybrid solution where, yes, you have TE, but there are challenges with TE as well in terms of vulnerabilities. There are quite a lot of these vulnerabilities that pop up. So you can use a combination of multi-party competition, MPC, or you can use other crypto economic incentives, basically. Where Akash, we have something called audited attributes. We have decentralized set of auditors that audit someone's, identity and whatnot. So there's that aspect as well. When you want upper levels of trust, say you're running healthcare data, you want absolute guarantees that this healthcare data is going to be staying in a region. There are data residency requirements, a lot of things you can do with audited attributes that you cannot just do with TE. But TE solves 99% of the problems when it comes to verifiability and confidentiality.
Yeah, this is very encouraging to hear from you as well, because this is what we work with at Oda AI as well. So running inference and TEs, and in my mind, it's also the most efficient way to solve for these 2 issues. There is obviously these other approaches as well, right? Like ZK and FHE and things like that. But I mean, especially for something like running an AI model, it's just not feasible yet, right? These solutions.
Yeah. So you can do some small sampling using FHE. You can do, there are combinations. I mean, every approach has its, trade-offs, right? Obviously, most of the trade-offs with ZE and FHE is latency. It's just significantly higher latency than TEE. But if you can use random challenges, a combination of these methods, I think you can build a very secure system. The answer is never usually in a single system.
Hear you. So let me see. Where do we take it from here? I mean, I believe you guys are looking, or Akash is looking for a new home in the sense for the protocol. I believe thus far it was or is a Cosmos, a chain built on the Cosmos SDK, right? Or I guess you could say an L1. But I think you announced that you're looking to bring Akash to a new home or like a chain ecosystem or something like that. So how is that going? What's happening here?
Yeah. So we announced that we're looking for a new home, primarily because the economics need to be optimized, where we do not spend as much as much as we do on securing the chain, because our value in securing the chain or running our own chain is very minimal versus the value we provide, which is compute resources, right? So we don't really take advantage of the layer one capabilities. And second is, we are on Cosmos, we're very isolated in terms of composability with other chains. The incredible primitives on Akash, um, all the way from being able to get resources, fully non-custodial manner, and they're also like economic primitives where you have yields, you have all kinds of real yields. These are from people that are using AI. It's not some fake token economics trying to just pump up your short term stuff. This is real long term yields. You have all kinds of amazing primitives that are on chain but fairly isolated with Cosmos. So we're looking to optimize our economics and open up our gates to the rest of the world. We're like Japan, basically. We're running our own little thing. We've been isolated for a long time, and we all know what happened when Japan opened up to the West, right? So we're looking to do the same thing. There are incredibly promising ecosystems. When we announced, we had about 18 chains that reached out to us that wanted to home Akash, which we are very incredibly excited and grateful for for these teams to reach out to us. We're going to do everything in the open. Of course, there are lots of offers and all the good stuff, but like we do, like we do everything, we do it in the open. We do it publicly. So it's going to be a long process to evaluate these chains, because we're going to give each chain the same opportunity that we give every other chain. There are certain chains like Solana and Ethereum ecosystem in the sense of talking about all the L2s, that are a lot more aggressive than others, in terms of how they approach us. So, but we're not going to make any favorites, because of how aggressive the sales teams are. But we're going to be extremely thorough and diligent, and also like document our findings. Like, why did we not choose a chain? Why, right? We have to produce our RFP very soon. We're being fairly busy with mainnet upgrades and a whole lot of product launches. We have a launch coming this Friday. So it is a 1 year process, probably longer. We're not in a rush for sure, but at the same time, we want to do it well. Yeah, and also when we made the announcement, it was the least exciting, according to me at least, the least exciting thing about moving chains. I mean, we made a lot of other stuff that we announced. People, for some reason, need to focus on the drama and and new chain, because like there's going to be very little experience or change in how users use us. I mean, that's what we want to be least disruptive, in terms of usability, because our users don't care what chain we are on. Our users are primarily AI users and AI developers. They really don't care. No, don't don't care or know what chain they should be using. Just like when you use Uber or when you use Facebook, you don't really think about it. Facebook is written in PHP, Uber is written probably in Go, right? You don't think about what the backend is, and that's how it should be. But the blockchain infrastructure in general is very primitive. It's very, very time consuming. It's very challenging to move these chains, and interoperability hasn't quite kept up with its promise. And so we're it's going to be a long process.
So what about, you mentioned layer one capabilities, and in a second you have to also give us just a general summary about Akash, because not all everyone will be familiar, but just curious about this because so you see the advantage of having your own chain negligible in terms of the primitives you can have on the blockchain protocol level, which are like customized to your application, right? You can, I don't know, you can define some transactions as feeless or something, right? Like maybe some sort of heartbeat pings to the compute nodes that you have or something that go to the chain all the time and influence something on chain. Or there's some creative freedom that you have if you have your own chain, but do you think this is negligible and you can bring all that to another chain?
Yeah, in 2025, all that is, you have data availability solutions to bring a lot of data on chain. You can still run verifiers and all the good stuff without being a validator. You can have a lot of capabilities that you would get with your own chain, right? And plus, on top of that, if you really need to go down to like you want to customize a validator, there's every ecosystem has their own primitives on how you can achieve that. Like Solana has something called network extensions, which can you can extend. There are a lot of options now. That you can be a layer 2 where you don't have, you can do a zk rollup where you basically are not running validators but just routing up to the main chain. You get, there's a lot of incredible like design patterns that are available now that weren't available, let's say 5 years ago when we began Akash, right? So
you're very open right now to what it will end up being, like an L2, or you're on an L2, or you're on an L1. It's just like all these different ways to take it.
Yeah, so we're calling it a shared security migration. We're not talking about L2, L0, L3, whatever, all these acronyms, right? We want a shared security instead of a sovereign model, because we don't, we feel like we don't need sovereignty at this point. Maybe in the future we do, right? I'm not sure yet. At this point, I don't think is optimal. Just like the way you think of it is like you live in a massive mansion in the woods. Great, mansions are great, but there are a lot of light bulbs you need to change. And you're a single guy, like you're just want to be nimble, you want to move fast. And ideally, you want to move to an apartment in New York City or somewhere where you have a lot of opportunities, a lot of flexibility. Sure, you pay rent. You don't have sovereignty. You can't make changes to the building like the way you want to. But the real question is, do you need to? That's what it comes down to. We determine that we don't need to. I mean, the amount of transactions we do is not that heavy, like a perp dex, for example. If you're a perp dex, yeah, you probably need to have low latency. We don't need, I mean, our settlement time is like 6 seconds and people seem to be okay with it. Sure, we can use faster transactions. Actually, we love to have faster transactions, but having your own chain, that means faster transactions means bigger block space, and I mean, a lot more block space, a lot more expensive. So layer one at some point becomes a burden more than a benefit. And right now, as Akash is getting bigger and bigger, we've been around for 5 years. You can see the ledger is like hundreds of gigabytes at this point, reaching about terabyte. To have a validator with a full state, that is extremely expensive to run a validator. It's increasingly becoming expensive to run a validator, right? So we forecasted the model. We said, well, if you continue down this path, our validators are going to get to a point where it's so expensive, our security budget just goes up and up, increases. So it just doesn't make sense to continue down the path, and we are responsible as the founders and core contributors to the network to find a viable path. I think the Cosmos model in general has failed. This is coming from someone who's been in the space for a long time, Akash being one of the first Cosmos chain. The model where it failed is sovereignty before product market fit. It should be flipped. I think you should go with PMF first and then sovereignty. Just like how you do on the web, right? You don't go build your own data center when you're shipping an app. You literally use something called like a Vercel or a Heroku or some shared system where you can easily get push and like get to customers, get validation, get product market fit, and then scale. You don't do opposite. Any company that does the opposite is guaranteed to fail, right? Like when you see like engineering teams for a startup company that raise $1 million, go and build a data center or like have your own servers. That, I mean, if you have the need for it, sure, but if you don't have the need for it, I think that's just a waste of resources and waste of time, and the amount of maintenance you get with it is just enormous, right? Like it took about 18 months for Akash to upgrade our source code from like an older version of Cosmos, I don't remember which one, to 5.3 or 053 version. And there has been zero customer forward or functional features that we delivered. This massive upgrade that tells you that we did all this work just to keep up.
It has no impact on the product. It's just like infra stuff you have to take care of.
So you can imagine the kind of damage that did this upgrade, because we rather spend that amount of energy and money on shipping customer features in this extremely fast moving AI world, because the demand is just higher and higher and higher. But instead, we had to focus on upgrading the blockchain, which is kind of useless. So I think teams need to really think through what the strategy, what the go-to-market is, and just not blindly go with the layer one. That's where I think Cosmos failed, and they haven't quite figured out how to bring shared security to Cosmos, and not for lack of trying. We funded efforts, several efforts to bring shared security for several years. We spent a lot of money working with Cosmos teams and other teams to bring shared security, because we knew without shared security layer, Cosmos will be absolute failure. And if Cosmos is a failure, we'll fail, because there won't be any 1-2 sentence upgrade. So we tried to bring, and for reasons I don't want to get into, Cosmos never figured out a shared security model. Like even now, like Atom as a blockchain doesn't do anything. Like there's nothing that runs on the Atom blockchain, right? The Cosmos hub. It could, sitting on $2 billion like economic security, like what's the point of having so much economic security where you have zero applications running? There's a lot of criticism I can give about like failing to figure out a shared security model on the Cosmos that is leading us to this path.
Yeah, very interesting. Tell me a bit actually about Akash, the product, right? What you guys do with the GPUs and the GPU marketplace and everything, just so people also learn about that.
So Akash is, in simple terms, a peer-to-peer marketplace for compute resources, right? So cloud-capable compute resources. That means if you use Amazon Web Services or Google or Microsoft, any of these cloud companies, you're essentially using a computer. You're leasing a computer. Well, turns out there are a lot of computers around the world that these big companies don't own, especially with GPUs, especially with AI. Because there are a lot of companies that want to keep their GPUs, because GPUs are extremely valuable. If you have a GPU, you keep them. You never know when you might need them if you're an AI company. But a lot of these companies don't need the GPUs all the time. So they come to Akash and they lease them out, and users that want these GPUs can lease them out on demand with a price point that's extremely transparent. And usually the value prop is significantly lower prices than what you would otherwise pay the cloud, because cloud companies are margin-based companies and they do want like profits. Whereas our providers are not cloud companies. And there are a few cloud companies, but most of them are actually AI companies with extra resources that want to get something out of their underutilization. Right, so that's the model, and it's been thriving. I think we have 10x revenue in the last year, and we're growing pretty aggressively. We're we're adding new capabilities this year and quarter one that will expand our market reach quite a bit. Akash is what we call container native infrastructure now. We're expanding to virtual machines and whatnot, and even in bare metal, you can get access to. I think we'll be one of the first ones to do that for a decentralized network. And so what goes on chain is the coordination part, basically the way to get resources and way to pay for these resources, whereas the actual compute is off chain.
Okay. What's some of the next features coming up?
Big features coming up this month, ideally in the testnet, is a improved token economics using something called burn mint.
Oh, that's MBE, is it?
Burn mint equilibrium. Yes.
Yeah, but I would love to talk about that. I have that on list because I looked into it. I saw your post, I think, on social media, and then I read the proposal, and I think it's really interesting. Can you tell me a bit about BME or the listeners?
Yeah, so BME is an answer to needing stable payments for exchanging value on Akash, right? So Akash has a native token called AKT. It is volatile. It is the primary way to pay for resources in Akash. But AKT is volatile, right? So it's bad for either the payer or the provider, especially when you have long-running workloads. Say you have workloads running over a year. The value of Akash could change drastically during which time. So that impacts either the buyer or the seller. So we want to introduce stable payments, right, without compromising Akash token, because Akash token is important for security. It's important for ecosystem. It is a very governance, for example. There's a lot of other utilities that Akash is very, very crucial to. So to enhance AKT value, that means bring structural buy demand for AKT, while having a stable exchange of value, is what burn mint equilibrium brings to Akash. At a high level, the way it works is you burn AKT to get an intermediary token, which is pegged to a stable currency, to a dollar, basically. This intermediary token is non-transferable. It can only be used to pay for compute, so it doesn't have liquidity independently. And the provider on the other side mints an AKT token with the intermediary token called ACT to get liquidity. And the way Akash works is you normally top up because there's an escrow layer in the middle where the tenant has to put some AKT into the escrow that gets converted into ACT. So there are top-ups that happen periodically, but the payments happen in a stream, in the sense like as the providers keep providing the services, they get paid. So we are betting on the fact that there are going to be more top-ups than payments. So you can imagine that means there'll be more AKT that's burned than minted. On a net, you'll have a deflationary aspect for AKT. So there'll be less AKT in circulation. And also this brings more utility to the token, more volume as a function of it.
Yeah, I think this is a pretty cool concept. I think another way to think about it is, maybe you mentioned it, but it's who wants to see their balance move, right? Like if you hold in a balance in escrow or whatever, that with which you can access compute. If the price of this asset is volatile, right, then you see your balance move essentially in how much compute you can afford with it. And that's a totally foreign or not really user-friendly concept, right, to users. I mean, if you have bought something and you knew at the time it's worth this much of the thing you want, you don't want it from 1 hour to the next to change, right, in value.
Mm-hmm. Yeah.
So this is really cool. But another way to also let me say this, isn't also another way to think about it, that you're essentially the price volatility is essentially outsourced to the protocol, because so I understand what you're saying, that you could see more burns than mints, but you could also end up let's say between the burn and the mint, the price of Akash tokens goes down, right? You could end up minting much more Akash tokens into the compute provider wallet that was burned
If
before.
the compute providers choose to mint AKT. Yes.
So the compute provider first receives the stablecoin as payment?
So say I top up for $100, right? So I burn 100 AK. Say AKT price is $1, just to give you an example. I burn $100, right? $100 worth of AKT. And I mint 100 ACTs, or the compute tokens. These compute tokens are paid out periodically. Let's say every day, about say 1 or 2 tokens are paid to the provider.
Is it not usage based? Like however much?
Yeah, it's say that you use for a day, you get paid for a day, right?
Okay.
But there's still 100 AKT that's burnt. Okay.
Yeah.
The provider just gets 1 AKT per day. Hypothetically speaking, just do the math simple. So it'll take 100 days for the provider to mint all the AKT that's been burned. So the more customers we sell, the more burns AKT will have. There'll be more deflation. Yes, theoretically, if the price comes down, there'll be more AKT that needs to be minted. But to avoid a price, I guess, depression, we remove circulation by optimizing for more top-ups and also more use cases for ACT as well. So we're also introducing several programs on the provider side where you need to burn, or you need to have a certain amount of ACTs in balance to bid on a workload. So there are other mechanisms where the providers are required to have ACT balance to do so. And providers are okay because the value doesn't change because it's dollar value, right? They're okay as long as it's not volatile. So the idea is to create more deflationary mechanisms for Akash using BME. BME is a foundation that you can build upon.
But the daily mint into the daily thing that the compute provider receives, is that still in the ACT compute token, or is that in...
They get ACT and they have to remint to AKT. I would assume they would.
So the compute provider himself has to do the action of minting. Correct. Okay, of course that adds a bit of a manual labor thing, which not everyone will do. So
it could be automated. It's up to them. Some choose to automate, some choose not to automate because there's other use cases for ACT, right? So you automate what you need to liquidate, essentially. We're banking on the fact that there's going to be more ACTs in the system.
Okay, so theoretically, the thing I said is possible, but for one, the payouts are more gradual than the top ups, and this structurally this also helps to counter like price depression, right?
So the idea is there'll be a lot more support during the downturn, and of course during expansion, it's going to be a lot more. Of course, deflationary mechanisms really work well when you have expansions, but in a depression or contraction rather, it'll be a lot more smoother in terms of contractions. So I think this is going to make the AKT token much stronger than what it is right now.
When is that coming out, or when will that be on?
We're targeting this month. Hopefully, we'll get it out, or at least in the testnet. Let's see.
Have you seen similar concepts elsewhere in crypto? Like, how did you?
Helium does it. There are other tokens that done it pretty well. I mean, the one that did really well was called Terra Luna. Unfortunately, the problem is they created liquid. The problem with Terra Luna was they created hyper demand for the UST and they made it liquid. The difference is, in our case, ACT is illiquid. It cannot be liquid. So we're creating demand for ACT in other ways that is not, say, yield farming, right? Because that's what really ran up Luna token, because people are burning Luna to get USD. USD is giving double-digit yields as a stable token. So there were a lot of burns for Luna that went into like top 10, right? So you can see it work in the real world, how a BME model would work. So in fact, we're using some of the same code that Luna did.
Okay, the difference is you can't transfer that this compute token. It's bound to the wallet that mints it or burns it, right?
You can only use to pay for compute.
Yeah, but you said you will add maybe more use cases. So what will those be?
All payments, right? So payment for, like, we have a new service called Akash ML, which is inference on demand. So you can use ACT to pay for inference. We have other managed services like databases and a whole lot of things. Only payments, right? So that means I cannot list ACT on an exchange. So it cannot be transferable from, say, I want to send you ACT. You have to be a payment, you have to be a vendor on the network to receive that ACT. Or else you'll create a liquid market, and then that leads to all kinds of problems. And then that basically, only way to get liquidity for ACT is through AKT. And it's very important because, or else it'll just run away as a stable coin, which we're not interested in doing.
Okay, super cool. You said that 99% of decentralized AI today is vaporware. What do you think is worth paying attention to?
Well, Akash is the first decentralized compute marketplace. There have been 100 computer marketplaces that came after Akash. Most of them are just not decentralized in any manner. They're just SaaS apps, right? So ignore anything that's closed source, ignore anything that's not on chain, ignore anything that just because something has a token doesn't mean it's decentralized. So all that is junk. They're just like hosting providers. They're not anything decentralized. The real interesting stuff, I think, in AI is distributed training. There are a bunch of companies. I don't want to name who, but a lot of the companies that are actually doing meaningful stuff doesn't have tokens in distributed training, and that's how it's legit. And they probably raise decent amounts from legit VCs. I think besides training, there hasn't been anything that's exciting for me in distributed, decentralized, in crypto in general, right? And even the training networks, there are a lot of these saturated networks now. Everybody's just like stealing everyone else's work. Even the legit teams are just stealing from each other. There hasn't been a platform where you go and be like, hey, I'm going to contribute my compute to this training run. I want some tokens back. That's the holy grail we're working towards, right? No one has quite figured that out. There's an opportunity there. There are a lot of primitives being built right now, but nothing cohesive in terms of a framework that can bring all these primitives together, or even a platform that can bring all the primitives together and make it as easy or as interesting as DeFi was during DeFi summer. That's really where we're going. Akash is, obviously, being a foundational player for a lot of these decentralized primitives. So, we have something in the works that we're working, but I think there's an opportunity there. There's a lot of the agent stuff is just vaporware. I'm kind of disappointed with. Recently, I saw a token. I don't want to name who it is, but they've reached like top 50 in a month and crashed down to like abysmal. I knew the team. I they were decent people. I don't think they I have no idea what's going on. But when I see stuff like that, it's a clear pump and dump. It's disappointing to AI. So obviously, avoid anything vaporware. Avoid all memes, in AI memes, and we saw this like mass amount of agents with like an Twitter agents that pop up and create all this like zero. Just really focus on like fundamentals, right? Like, look, the way I look at what's exciting is there obviously people using it? Is there utility and people using it? Number two, if I'm buying something, what is the chances that I'll get my money back? Like, what is the fundamental driver? Where is the buy demand coming from? Like, that's not speculative. So if you cannot find an answer for non-speculative buy demand, that's a vaporware, generally speaking, right? A lot of the companies that are well-funded haven't quite kept up to their promise. A lot of really good papers, but nothing really in action. So, most of the stuff is vaporware, unfortunately. Only thing that has some meaningful product market fit is marketplaces, right? Because you have GPUs and people want GPUs, and that's not hard to hard to know. Beyond like GPU access, compute access, training is not there yet. I mean, I wouldn't call training a vaporware. That's really promising, like we discussed. Inference, decentralized inference is complete vaporware. There hasn't been any promise verifiable inference that's actually real anymore. The whole like data confidentiality, I'm not very excited. I mean, there has been some excitement, but there hasn't been any progress. There are a lot of good pitches, a lot of good projects pitching, but haven't seen. Maybe I'm not up to date on what's happening with the data privacy folks, but it's always been in promise, right? And you saw OS like abysmally fall the data privacy space. The new projects that are coming out, bigger promises. Want to wait and see. Yeah, unfortunately, I don't. Can't really say what's exciting. I mean, there's a lot of exciting stuff outside crypto that I'm looking at, right? Like there's a new chip company, there's new energy companies, the new batteries stuff. That's really exciting. I'm very excited about a lot of the nuclear stuff that's happening, especially deep fusion nuclear. A lot of space stuff that's happening that I'm excited about. The data centers in space that's very fascinating that I'm looking at. Yeah, that's the state of the industry.
All right. I mean, let's wrap it with that. Greg, thank you for coming on the show, man. It was a great conversation.
Yeah, likewise. Enjoyed.